Have you ever wondered what happens when stars are born in a massive cluster? Imagine if we told you that some of the largest stars in the universe are being hurled into space at incredible speeds, never to return. That's precisely what's going on in a star cluster called R136, situated in a remote satellite galaxy of the Milky Way. Get ready for a cosmic journey. R136 is a huge cluster of stars that's located inside the Tarantula Nebula, which is in a satellite galaxy called the Large Magellanic Cloud, which is about 160,000 light-years away from us. While the Large Magellanic Cloud might not be as well known as our own galaxy, it's a neighbor with a few fascinating secrets. One of the most impressive features is the Tarantula Nebula, which has been producing huge numbers of stars for millions of years. And what about R136? It's the heart of this stellar forge, containing some of the most colossal stars known to humankind. It's been known for a long time among astronomers that star clusters can be pretty chaotic places. After all, we're talking about hundreds or even thousands of young, hot stars packed into a relatively small area of space. The stars in R136 are some of the most massive and energetic in existence, and they're just a few million years old. Just to put things in perspective, our Sun is about 4.6 billion years old. These stars are practically infants, burning brightly and living fast in comparison. But here's the interesting part. Some of them aren't going to stick around. As it turns out, many of them are being ejected from the cluster at incredible speeds, some over 100,000 kilometers per hour. That's fast enough to escape the cluster entirely and set off on new journeys across the galaxy. So how did we find out about these runaway stars? We have the European Space Agency's Gaia satellite to thank for that. Gaia has been scanning the skies since 2013, measuring the precise positions and movements of stars across the Milky Way and beyond. Recently, a team of astronomers, led by PhD student Mitchell Stoop from the University of Amsterdam, used Gaia's data to uncover something astonishing. At least 55 stars have been ejected from R136, speeding away from the cluster like cosmic cannonballs. And the number might be even higher. The discovery is a great illustration of just how violent and unpredictable star formation can be. When stars form in clusters, they often interact with each other in chaotic ways. The gravitational tug-of-war between stars can result in some being flung out of the cluster entirely. It's like a cosmic game of pinball, where the stars jostle and ricochet off one another, and eventually, some get tossed into interstellar space. But this isn't a new thing. The team's research suggests that stars have been getting ejected from R136 for millions of years. The first major event happened around 1.8 million years ago, not long after the cluster was formed. Back then, the stars were sent flying in all directions, seemingly at random. But something interesting happened more recently, about 200,000 years ago. Another ejection event occurred, and this time, the stars were thrown in a more unified direction. So what changed? The astronomers think the answer might lie in another nearby star cluster that wasn't even discovered until 2012. It's possible that R136 and this neighboring cluster are on a collision course. Their gravitational interactions could be causing stars to be ejected more systematically. In fact, this could be the prelude to something even bigger. The two clusters might eventually merge. When that happens, it could trigger even more star ejections or possibly create an even more massive cluster. It's a fascinating glimpse into the dynamic and ever-changing nature of our universe. But why does this matter? After all, space is huge and stars are constantly on the move. What's so special about a few stars being thrown out of their home system? It's possible that these ejected stars could have a significant impact on their surroundings. As they speed away from R136, they could have an impact on other parts of space. Some of these stars will eventually explode as supernovae, leaving behind neutron stars or black holes. Supernova explosions are incredibly powerful events, and they can send shock waves through the surrounding gas, triggering new waves of star formation in distant regions. This means that 136 could be indirectly seeding other parts of the galaxy with the raw materials needed to form new stars and planetary systems. But there's an even bigger implication. It seems that the ejected stars from R136 and others like it throughout cosmic history may have played a part in one of the most critical periods in the evolution of the universe, the era of reionization. This was a time when the first stars and galaxies were forming, and their ultraviolet light started ionizing the surrounding gas, transforming the universe from a dark, neutral state into the bright, energized cosmos we see today. The ultraviolet radiation from these massive, short-lived stars could well have contributed to this monumental change, helping to shape the structure of the universe as we know it. Let's take a closer look at the stars themselves for a moment. What makes them so special? The stars in R136 are pretty special. Some of them are among the most massive ever observed, with masses hundreds of times that of our Sun. These stars burn through their nuclear fuel at an incredible rate, fusing elements in their cores at temperatures and pressures far beyond anything our Sun will ever experience. This means their lifespans are incredibly short, just a few million years compared to the billions of years that more modest stars like our Sun can expect. In a cosmic sense, they are the ultimate live fast, die young entities. And when they die, they do so spectacularly, detonating as supernovae and leaving behind either a dense neutron star or a black hole. These huge stars are also responsible for enriching the universe with heavy elements. When they explode, they scatter elements like carbon, oxygen, and iron into space, which will eventually be incorporated into new generations of stars, planets, and even life itself. As it happens, the iron in your blood and the calcium in your bones were created in the heart of a massive star that lived and died long before our Sun was born. The stars in R136 are continuing this process, creating the building blocks for future cosmic generations. As for the ejected stars, their fate is already sealed. Once they're flung from the cluster, there's no chance of them coming back. Instead, they'll wander the galaxy, isolated from the chaotic environment of their birthplace. Some may find themselves in quieter neighborhoods of the Large Magellanic Cloud, while others might cross the vast intergalactic void. Eventually, many will meet their end in brilliant supernovae, their light briefly outshining entire galaxies before fading away. So, what's in store for 136 Rand? The cluster is still quite young and has plenty of life left in it. As it keeps on evolving, we might even see more stars being ejected, especially if it merges with its nearby companion cluster. Over time, the cluster may disperse, with its stars being flung far and wide across the Large Magellanic Cloud, contributing to the ongoing cycle of star formation and destruction. But for now, R136 is still a great example of stellar activity. It shows us that even in the quiet depths of space, incredible forces are at work, shaping the universe in ways we are only beginning to understand. This is just the latest step in our journey to understand the universe, and it shows how much there is still to learn. Thanks to observatories like Gaia, we're learning more and more about how stars live and die, how galaxies move around each other, and how our cosmos is always changing. Watch this space for more amazing discoveries from far away as we keep exploring the universe. Thanks for watching, and don't forget to subscribe for more cosmic adventures.